Hello everyone. So now we are going to discuss subarray sums 1 and subarray sums 2. So let's try to understand this problem. So it is written that given an array n of positive integers, okay, an array n of positive integers, the task is to count the number of subarrays having sum x. So simply we have to give the count of subarrays whose sum is x. And what is subarray? Subarray is like continuous segment, na? Like 2 4 could be a subarray, 4 1 2 could be a subarray, entire array could be a subarray, 1 could be a subarray, 2 could be a subarray, like continuous segment. Okay, so the task is to count the subarray of sum x. And what is the constraint? Okay, n is varying up to 2 10 power 5, and we have the element sum as 10 power 9, and each element has 10 power 9. Okay, great. Okay, let's also see the sum of 2. In sums 2 we have array of n integers. Great. Task is to count the number of subarrays whose sum is x. Okay, this part is same, but here the only difference is here we can accept negative numbers too. Okay, so here we had only positive numbers, here we can have negative numbers too. So that's the difference between sum 1 and sum 2. Okay, so try to solve this on your own first. Okay, so let me share my approach. So what would be the brute force approach? Simple, n square, pick any two I and j, get the sum. We can go for big of n square easily, but can we do better than that? Because big of n square wouldn't work here, but it will go up to 10 power 10, and that's not permissible for us. Okay, so let me share my approach. Okay, and this is simple. Think of a 2-pointer, you can say, or sliding window concept. So first of all, I created a prefix sum vector. Okay, so I define the input the n size and the sum as x. We have inputted. We defined a vector with long. I kept long everywhere because the variation were up to 10 power 9, and we will be adding things, it will go more than 10 power 9. So I kept a long everywhere. So here we have created the prefix sum vector. Okay, after that I kept 2 pointers I and j. Okay, so think of it as like sliding window. Okay, so what I will get doing was getting sum is equal to prefix j minus prefix I. Okay, and if sum is equal to x, so what is x we are asked, then count plus plus, like answer plus plus, and the last element of the previous I plus plus. But if the sum is greater than x, if sum is more, we have to reduce the sum. How can we reduce the sum? We can do I plus plus, like smaller index plus plus, and if the sum is less, we go forward, we can do j plus plus. Just think of this part, it's very important. In some logics you will say it is written like first and the last, first second, or the start and the end. No, high and the low, you can see you define some kind sometimes in that as those variables. Just visualize this part, how we are moving the sliding window. Simply I kept 2 pointers only. Okay, 2 pointers, I used those to get the difference between those two indexes. Those two difference, this is basically sum of these two numbers in those two indexes basically. Let us think of this part. Okay, and if sum is equal to x, count plus plus, and why we are doing I plus plus? Because we are moving forward. Okay, and if sum is more, we have to reduce the sum. If sum is less, we have to increase the sum. Okay, and since we are using prefix sum and number positive, sum will be as increasing array, increasing vector. Try to visualize this part. Can we say this? Can we say that prefix sum would be an increasing vector? Okay, if the value is 0, we can say non-decreasing. Okay, non-decreasing because it won't decrease. It might be the same for some values. Okay, this part is important here. Think of this part. If you can think of through of this part, things will be very interesting. And but we can't use this approach in the second, like in the part 2, because we have negative values there. So we can't use this approach of, I call it earth form algorithm. I don't know what should we call. We have last, we have some front, and we keep moving forward and backward just to ensure that we got the sum of those subarray or those part of the segment of the array as x or whatever we need to find. And what we to do in subarray 2, we have negative numbers, so we can't simply use this concept. Actually, we can't be sure. Like here we can easily say, okay, if the sum is less than x, go for I plus plus. Sum is Sum is more than x, go for I plus plus. Sum is less than x, go for j plus plus. Okay, like sum is more, reduce the sum. And how can we reduce the sum? We could do I plus plus. If sum is less, increase the sum. How can we increase the sum? We can do j plus plus. But we can't say the same in a negative vector, like a vector made of negative elements. Think it through. Like, why can't we say the same? Okay, so in that we can keep a map. So we kept a map of storing the like count of each prefix sum. Okay, let's say I started the prefix sum as 0. I started taking in the values. Okay, let's say we call it LL val. I inputted it. So I in the prefix sum I added val. Okay, now I was checking. Can you find any element with prefix sum minus x? Why we're looking for this? Because we will do x minus of this minus prefix x plus x. Okay, no, prefix sum minus x. Okay. So actually we have reached up to prefix sum. Okay, how can we explain this part? How can we say this? Prefix sum minus. Okay, why are we doing prefix sum minus? We have x. Okay. So moving forward, we are doing prefix sum. We are looking for prefix sum minus x. And if it is represented in a map, simply do plus plus. Map plus plus because we have got this. Okay, we have got prefix sum element and we are adding here plus equal to of map of prefix sum minus x. How can I explain this? If I were looking for prefix sum minus x, prefix sum minus plus x. Okay, yes. Okay, how can we explain this? Okay, so basically we have reached up to prefix sum. Let's say at any index position. So if let's say we have to find k element, so prefix sum minus k should be equal to x. So think of this part. This is simply prefix sum. So what we do prefix sum, we basically subtract two positions and we get the sum of those segments. Okay, let's say there are 10 elements. Let's say there is an array of 10 elements. So you define array of 9 will be that up to 10th position minus array of let's say 4. So using this, what will you get? You will get the sum of factors from the 5th position to the 10th to last. Okay. See if I make a mistake here. Okay, I made some speaking error, but think of this part. So how we define prefix sum? We are just simply adding up the arrays from 0 to up to n minus 1. And what we are ensuring here is when we do prefix sum a minus b, so we are getting the sum between from b to a. Just think of this part. So that's why we are doing this. So let's say if we write this prefix sum minus prefix sum plus x. Prefix sum will cancel out, we will only get x. So the difference between v prefix sum of a minus prefix sum of b will be x. So that's why we're looking for this. Okay, so what we're doing here, we are keeping a prefix sum variable. Other than that, we are keeping a map. In the map, we are just simply putting all the prefix sum values, and at each position we are checking if do we have prefix sum minus x in the map. If we have it, simply count plus equal to map val, like whatever its value will be, we are simply adding it. How many times it has come? Let's say it has come at various position. We can't do this in here because it will only come at one position. But here it might come at different position because the sum of certain segment might be 0. Okay, so that's why we need to go through this approach. Hey, it's becoming difficult to explain, but just try to think of this part why you're using map and why you're not using map here. It is very interesting here. This is very basic and standard problems. Okay, and if we time to go for time and space complexity, so what we have did here, okay, we have kept a loop. Okay, let's for this part. Hey, simply big of n. See, we're simply iterating once. It will be prox big of n only, and space complexity will be big of n because since we're defining vector, all are simple other variables only. And here what we're doing, we are keeping a map. Okay, we are showing a map, and map go for log of n. Okay, so we have iterating for the loop of n variables, and here we have log n. So n log n will be time complexity, and space complexity might be big of n if in the worst case. See, because if the prefix sum, like if the piece of the prefix sum we are getting is distinct, so we have to save too many keys. In that case, it might go up to big of n. Think of this part. If we have used another map here, so if you use another map, so this it is this thing like searching would take only a big of one space, so it would go up to big of n, but we are using map here, so it will go of n log n for times complexity, and for space, since this map, it will, in worst case, it will go for big of n. Okay, so just try to think that through these two parts, how, why are you using map here, why are you using map not, and try to solve it on your own here, because these are very standard problems. Okay, and also try to solve this problem. It's also very interesting. If you can solve subarray sums too, we can easily go for subarray divisibility. Okay, okay then, bye bye.